So welcome all. This is week 3 tutorial for the course Introduction to Machine Learning. I'm Pintu Kumar. I'm a PhD scholar at IUR IIT Bombay. So for this session, I have thought about covering the topics recommender system that was covered this week in this course. As well as if time permits, we are already 10 minutes late. So if time permits, we will look at K nearest neighbor that was talked in first lecture. Apart from it, this Manik is covering today feature selection, and he would be covering PCA and some maths behind PCA that was not discussed in the class. So if you are interested in knowing more about this also, you can join at 7 p.m. Using the link that is mentioned over there. Okay. So like if you have Arindan, you can definitely ask any questions from video lectures, and like you can ask even if you want now, you can ask, or later also you can ask. And if you have any doubt in the content that I'm teaching, in backward search, why we eliminate features with smallest impact. Dashikar, can you hear me now? Arun Sharma, yes. You can turn on your mic any moment you want. If you have any doubt, you can ask.
Could you share your YouTube link with us in chat box?
So YouTube link would be created after I have uploaded this. So if you go to your swayam portal, you will find an option of live sessions or something like that. There you will find an Excel sheet. It gets updated over there. So most probably by tonight it will get updated.
Okay, thank you.
Yes, I'm not allowed to solve a current assignment problem, but I'll try to solve similar problems that will help you attempt the
Sir,
assignment problem. Yes. Who is this?
Pulkit speaking here.
Okay.
Sir, I enrolled for this course on 28 July.
Okay.
My laptop doesn't work, so it is in the care at Delhi, and I have not attended any of the class and I not submitted any assignment. So
See,
what can I do now?
see, this live sessions are not the regular class. This is for doubt session and those kind of things. Okay. So you just need to watch the lectures to get yourself like acquainted with the course, whatever is
Uh,
uploaded.
if I submit assignments tomorrow, then will it give a negative effect on my marks or not?
So I'll recommend you that you upload it. I'm not an official TA. I'm a PMRF TA to address doubts, but I'll send a mail to Professor Sudeshna Sarkar that you have this kind of issue, and probably she will consider it. So you send it.
Yeah, today I tried to call the NPTEL team, but they did not answer my call.
Okay, that's fine. I'll get in touch with the official TAs, and you can send it to them. You are Pulkit, right? I'll
Yeah,
get
and
it.
actually, till now I had not got my laptop repaired. So maybe on Monday I will get it returned.
Okay, that's fine. So Arindam, it's very difficult to like point to the exact time you're talking, but I'll tell you why in backward the search we eliminate the feature with least impact. I'll give you an example first. Okay. So let's say you want to find a predict age of a person. Okay. And so the features that you are looking at, like you have a photograph of that person, you want to find the age of the person. So from the photograph that you have extracted features like let's say face texture, okay, hair color, okay. Now, and something like a color of clothes that the person is wearing. Now, if you use all these three features to train your model, and whatever loss you get, you note it. Now you keep removing one by one. You removed face of the like face texture. The loss function increased by something. Okay, so this what does this mean? Like if the impact of removing a like feature is more, what does this mean? This is an important feature. You should keep it. So if you are removing this feature, it will make a more impact on this loss function. Now, if you look at color of cloth, so it is an redundant like feature, right? So if you want to remove this, like if you remove this, so the impact on loss function should be very less. So that's why we eliminate feature with least impact. Does I make sense, Arindam? Okay. So Yash, I haven't seen the question number 7 and 8. Like I don't remember exactly what these questions are. If you can like type it out in chat box, I'll try to help. But today's session is basically on week 3 contents, like this. Uh, like if you have a question, you can post it in this forum. I'll try to answer it there. Okay. You can type it out. Like if it is related, I can like attempt. So today what I thought is I'll cover something about recommender system. This was covered in fourth. Okay, I'll have a look. You can just post it over there. This is like the fourth lecture that Professor Sudeshna Sarkar gave. It was covered there. So just to give you a brief idea what a recommender system is, like whenever you shop on Amazon, most of you would have, and like when you watch a movie on some streaming site, you might see something like recommendation that you are getting. Like you have watched, let's say, Lagan, then you might get suggestions or the recommend. Yeah, exactly, suggestions. So if you watch something like a movie called Lagan, then you might get recommendation of other Amir Khan movies. Okay. So this is a screenshot from my personal Amazon account. So there was a column called inspired by your browsing history. So based on whatever I have searched or whatever I have bought, they have recommended me to buy these kind of things. Okay. So here is another screenshot just for an example. Like this is for my Twitter. So based on whatever I do on Twitter, they have recommended me these kind of interest or these kind of topics that I might be interested in. Okay, so next is this is just an example like where this recommender system is useful. This is the people they have suggested me to follow, that I can follow these people because someone I follow follows him. Okay, so like recommending people like what they can do next, it's something what is at core of a recommender system. So based on the previous data, what you have to do is you have to like recommend the person what should be his next step or next thing to do. Okay. So other useful application can be movie recommendation. When you watch YouTube videos, YouTube recommends you videos based on your past things. Ads by Google. When you go to many websites, you see ads on Google, or ads sponsored by Google. So those ads are like what ad to show to what user is like done via these techniques that we are going to learn next. Okay. So to give you an like very brief overview about what a recommender system is. So you have a set of users. You can view users as us people, like when we go to Amazon. For Amazon, we are the user. You and me are the user who are going to buy something. And I is the set of item. What do I mean by set of items is the whatever is listed on Amazon. So some book is listed. So that is one item. Let's say they have listed some laptop, that is one item. Okay. So what you want to learn is over here, you want to learn a function S, which will take two inputs. That is one is user and one is item. And for every item and user pair, it will give you a real number. This is a symbol for real numbers R. So rather than real number, this can also be some Boolean set. But one thing to remember over here is this set should be totally ordered. What is meant by totally ordered? Totally ordered is a mathematical term saying that any two numbers are comparable. So for example, let's say you are mapping it to ABC, you can't map it to ABC. Like there can't be a mapping from U cross I to ABC because you can't compare what is ABC among themselves. So what we want is we want preference over here, like something is highly preferred than the other thing. That's why we look for a totally ordered set. Okay. So this is just an overview of what a recommender system is. Now, based on the technique that we use to recommend, recommendation system are divided broadly into two. Boolean. Okay, Arun, Boolean is something which can be represented by 0 and 1, true or false. Okay, so anything of this form is okay. How Boolean is, like whether a person would be interested in buying, if you want answer in form of yes and no, then you can map it to some Boolean sets. Okay. Okay, yeah. So there are two type of recommendation systems. One is content based. Okay, Putul. Uh, okay, so you all know real number. Okay. So if you look at any two numbers in real number system, I'm just giving you a brief idea what totally ordered set it, not going in like its theory. So if you look at any two real number, all of you can certainly say that 2 is smaller than 3. Okay. So for any set, like a set S is called totally ordered if like you take any two element out of it, A and B, then you can say either A is less than equal to B or B is less than equal to A. Okay. This is what I mean by totally ordered set. Now it would be more clear by a example that is not a totally ordered set. Now look at this example. So you take a set of all alphabets. Okay. So when you look at all the alphabets, A, B, C, D, so there is no ordering. You don't know whether A is less than B or B is less than A. This is not true. You can't compare these two elements. So this is not a totally ordered set. Another example is when you look at R2, which is your R cross R. Okay. So you have elements like 1 comma 2 and something like 2 comma 1. Yes, there should be a comparison between any two element that you see. So R2 is an example which is not a totally ordered set. So you can't compare these two elements. So we always want this core or the mapping that I'm saying in a set where any two elements can be compared. This is what I mean over here. Okay. So this recommendation system are of broadly of two types, and there are more types. Not actually categorical. You can have continuous like mappings also, but whatever you have to like you should be able to compare them. Himanshu. Yeah. So recommendation system are of two types broadly. One is content based, and another is collaborative filtering based. So this was covered in a bit of detail in this course. I'll try to like uh, briefly cover this also because this recommendation system these days are kind of very much used in industry and those kind of things. So yeah. So first topic that we are covering today is content-based recommendation. What is content-based recommendation? So in this kind of recommendation, like whatever we are doing is based on features of an item. What is an example? Let's say I'll take a example of movie recommendation. When I'm looking to recommend a movie, I'll create a feature vector out of it for every movie. Let's say the movie is called Lagan, I'll take again. Okay. So the actor over here is Amir Khan. Okay. Then I have some director. Then I have some actress. So combining all these things together, I'll get a feature vector for this movie Lagan. Okay. So based on this feature vector, I'll see other movies that are similar to this movie based on this feature vector. And then I'll recommend this movie to any user who have watched Lagan in past. So this is the basic idea of content-based recommendation that this similarity between movie year can be another option. So this is up to you how you design your feature vector. Okay. So similarity between like two items is your movies over here is based on the features that you construct. Okay. So for example, I've given an example over here. If someone has like Three Idiots, it is good idea to recommend PK or Dangal to him because it is like by the same like actor. So another example is like whatever he has purchased in past. Let's say he has purchased some pen and some notebook. So all these things are sort of stationaries. So it is okay to recommend him something like some books. So this is based on the features of this pen and notebook. not on what other users are buying. You will get a more clear idea when we cover collaborative filtering. Okay. So this is an any doubt till now, like what is collaborating filtering? Sorry, content-based filtering. Any doubt till now? Sorry, this is content-based recommendation. It is.
No, sir.
If okay. So how does this work? Like you go to some place to work and they ask you to deploy a recommendation system. What will you do? I'll sort of go step by step. What you need to do to make a recommendation system. So let's say you have some. I'll give you an example of movie only. Okay, you have a catalog of movie. What is catalog? Catalog is a list of all the movies that is available with you that you can recommend to a user. So for every movie, item is movie, you have to build the item profile. How do you build the item profile? That is up to you. Like what features to include, that is up to you. Using those features, you build item profile or the item vector for everyone. See, whatever Himanshu is asking, what should be a typical size of this? This is sort of a drawback of this content-based recommendation, that we don't know what features to use, like what is a good feature, what is a bad feature, how long it should be. So like you have to take input from the expert in that area. So if you are looking at some movie recommendation, then you'll have to probably talk to someone who is working in movie industry, and he can tell you like which features you should use, how long should it go. And this would vary from area to area that you're deploying in. So for shopping thing, this may vary. And for other thing, this may vary. Again, like if you are making your vectors too long, then you are making it difficult from computational perspective, data collection perspective. So these things you need to take care. So this is a drawback of content-based recommendation. So there is not a fixed number that you should have something around this point. You need some specialist from that area. So you need a human intervention that we say in this kind of setup. Okay. So now where I was, yeah. So our first step is for every item, you need to build the item profile. Yeah, domain knowledge is a good word. Now, based on the items that let's say you build item profile for every item, then based on the item that a user like, what you do, you create a user profile out of it. Let's say there is a person X, he liked these three movies. Let's say he liked Kabhi Khushi Kabhi Gum, he liked DDLJ, he liked Devdas. Now, based on this, you will build a user profile. What you will say that this meeting is he trying to join? Wait, I can't see any request to join this meeting. I'm really sorry. You can tell him there is some technical glitch today from NPTEL side. So this was supposed to be Manek's class, but they kind of switched the link. So I'm very sorry. Like if it is not showing for me to admit him. Yeah. So based on the movies that like he liked, yeah. So based on the movies that he liked, we can build a user profile out of it. So how would a user profile look like? We may infer that X likes movies that are like that has Shah Rukh Khan as an actor, okay, or something like Kajol as an actress. He liked two movies that were directed by Karan Johar, so he might like Karan Johar as a director. So these are the possibilities that we have. So after you have built the user profile, you match this user profile with every other movie that you have available in the catalog. Okay. Then whichever like movies matches most with this user profile that you have created, recommend that person that movie. Okay. This is an intuitive idea what you have to do. I'll repeat the steps what we have to do. You have to build item profile for every item. Okay. After building the item profile based on whatever he has liked, or in case of shopping example, whatever he has bought, you will make a user profile out of it. Okay. Now from that user profile, you will find the most similar item in your catalog and recommend him that product. So this is the basic framework for a content-based recommendation. Okay. I'll take an, so like when you deploy these things on via coding or this kind of thing, intuitions need to be converted into numbers so that your computer can progress those things, right? Process those things, sorry. So this is an like section talking about how can you make a user profile. Okay. Now item profile you knew, like let's say you gave the actor name. So I'll give you an example how to make a user profile also. Let's say you have a movie called let's say DDLJ. Okay. You want to build a vector out of it. Now vector should contain generally all the numbers. Even if you have you know these things, right? Like when you have categorical feature or when you have like discrete features, I would say it's good to convert them to numbers. Like let's say when you look at the name of actor, I'll give an example. I'll give a concrete example. When you look at name of actor, you can simply convert it to like let's say this can be Shah Rukh Khan or Amir Khan, something like this. You can convert it to this like numbers. You can, what you can do is you can keep the first element are those M cross N matrix. I don't see any matrix right now. Yes, so I'm just talking about a vector right now. Okay. So what I'm trying to say is like that the first element you can assign to let's say Shah Rukh Khan. If that person is present in that movie, you assign this number as 1. If he's not present, you can go for 0 at this position. Okay. Again, you can for the second position, you can use the second actor. And this way you can construct a feature vector. This would be a long vector this way, I would say. Okay. So for DDLJ, let's say that my first position was for Shah Rukh Khan and second position was for Kajol or something like this. Then I use this 1, 1 and something like 0 over it. So this is how we'll build a item profile for a movie. Okay. Now, when you have built the item profile, now how to make a user profile from this using these vectors. Now the first option is you can take average of all the like movies that the person has watched or liked. Okay, one option is this. Second is like some person might like some movie more than others, right? So every movie that you watch, you don't have same preference for that movie. So you can take a weighted average of these vectors based on the preference that the user have. Third option is normalize based on the average rating by the user. What I mean over here is, so in your friends also there might be some people like if they like the movie like even above average, they will rate them 5. Like if there is no drawback in the movie, they will rate them 5. But some people are very strict in rating. They will rate very good movie even 3 to 4. So the average rating varies from person to person. Okay. I'll explain Arun Sharma what is weighted average in just below this. So different people have different average ratings. So what we want is we want to normalize these ratings before giving the rating. So I'll just give an example over here. So there are two actors working. Let's first look at what this example means. So there are two actors, A and B. You can think them of any actors, and there is some person X. Okay. So person X watched 3 movies of actor A and 3 movies of actor B. For the first movie of actor A, he rated him 1. For the second movie, he rated him 4. And for the third movie, rated him 5. Now for actor B, he rated 1, 3, 4. Like even from naked eye, you can make that he preferred this actor. Okay, because every rating is greater than or more than that. But like there can be case like 1, 4, 5, but here you have 2, 5, 3. Then how to decide something like this? So I'll give you an like you have to choose which option is best over here. So what you should get is like the person should prefer this movie. How do we reach? Let's see. So now for every movie, we can build a like item profile, right? So for the first movie that he has rated 1, it had actor 1, but didn't had actor 2. So the item profile looks something like 1, 0. Similarly, for the second movie, which is your 4, it is also 1, 0, right? Let's take some random example. For this 4, so actor 1 was absent, actor 2 was present. So it is 0, 1. So this way you can build item profile for all the 6 movies. Now based on this, all these 6 movies, let me make the user profile of this person X. Now using the first option that was mentioned, that was taking average, like what we can do is we can take average of these vectors. What do we get? 1 by 2, 1 by 2. Now see that like it is giving same preference to the first actor as well as the second actor. So this is not something that we saw in the ratings, right? So this happened because we didn't take the weighted average. We just took the average. So even if he has watched the movie, we are weighing it on the same scale when he has liked that movie very much. This is what is happening over here. So to overcome this, we go for weighted averages. Okay, now Arun, your question comes, what is a weighted averaging? So weighted averaging is we'll multiply it with the rating that this person has given it to the movie. So if the person like the movie more, we will weight it more. So we'll multiply it by a higher number so that the answer that we are getting is like higher for that actor. This is what is weighted averaging. So the for like, I'll just show you this thing. So he rated this 1, 4, 5. So I multiplied this by 1, 4, and 5. Okay. 6 is the sample space here. I'm not sure in what context are you talking about sample space. So this is just, I had 6 movies available with me. So that's why I divided it with 6. If I had more movies, I would have divided it by more. Like you can have more movies, less movies. That this is not a sample space at least. Not actually. So what happens is, let's say you are the owner of Netflix for a day and you have 6 movies available with you. So you look at, you have, let's say, 10 movies available with you. You look at set of all the movies that are rated by the user. So this may vary from user to user. So this is not a sample space. Yeah. So I have taken the weighted average. Then I get something like 5 by 3 and 4 by 3. Still, if you look at this, this 5 by 3 and 4 by 3 are not very far away from each other. Okay. Uh, So what's the reason behind this is if you are given that the person likes a movie by the quantity 4 by 3 and 5 by 3, what you would say that he likes both the actors, right? So if he doesn't rate the movie, we won't use it to make a recommendation about. Okay, so I'll give you an example. So let's say Yash is watching some movie on Netflix. There are like, let's say 10 movies only available on Netflix. There can be many movies. Okay. So there are only 10 for the assumption. So Yash has rated 6 movies. Okay. So for rest of the 4 movies, we want to predict the rating. This is what the task is. So for the rest 4, we want to see whether Yash would be interested in seeing this movie or he won't be interested in seeing this movie. So to do this, we will use only these 6 movies to make whatever prediction or calculation we are doing. We will do only on these 6 movies which you have rated, and for the rest we want to predict. So it is something kind test and train kind of data set. So we have only those movie in the training data set that you have watched. So if you have not rated a movie, we won't consider it during our evaluation only. You can multiply it by 0, but that doesn't make any sense because you will increase this number over here. Okay. So, not actually semi-supervised. This, you can say this is all sort of different kind of learning, but this is not semi-supervised learning, to be honest. Yeah. So this is a different kind of algorithm that you're following. Okay. So next is what we can do is to normalize based on the average rating of the user. What advantage we'll get, I'll show it to you. So when you look at the ratings, it was 145, and for the next one, it was just let me see. Yeah, it was 134. I have made some calculation mistakes over here. I can see. Okay, this was what was available with us. So what's the average rating of the first user when you see? It's 145, so it is 10 by 3. For the next user, what it is? It is 8 by 3. So what we do is we subtract this average from every rating. Okay, it was 1 minus 10 by 3. Okay, now we have second is 4 minus 10 by 3. And the third one is 5 minus 10 by 3. So you see that the first actor's movie, he tend to rate them higher on an average. Okay. I'm sorry. Yeah, I was correct then only. So I'm really sorry. Like all these ratings are by same person, right? All these 6 ratings are by the same person. So we look at the average rating over both these actors. Okay, I'm really sorry for what I did. 145 and 134. So this is for the same person. Okay. So we'll take average overall. So what happens? 10 plus 8 divided by 6. This is 3. So average rating is 3. So when we subtract this from this, we'll get minus 2 over here, 1 over here, and 2 over here. We get minus 2, 0. And what do we get over here is 1. Okay. Now what we do is, which portion, Arun? Which portion do you want me to repeat? What I'm doing is, I'm looking at the average rating of that person. Okay. So he rated these movies as 145, 134. So what I'm doing, I'll just take average of all these movies. Okay. So average rating is 3 that I got. I added them and divided by 6. And then I subtracted this average rating from every rating that he had given. Okay. Now when I take this weighted average, I get something like 1 by 6 and minus 1 by 6. You can do easy calculation. This is minus 2 plus. You can easily do this. Okay. So what does this show is that this quantity is positive. What does this mean? That this person is attracted or like not attracted but wants to see movie of actor 1, actor A. And what does this mean? That he is not interested in this kind of movie, so one should recommend this kind of movies to him. So this was an example how you can build user profile. Okay. Now you have built this user profile for a person. What next I said you have to do? Next you have to do is uh, you have to match this Dr. Mahadev, you just need to take weighted averages. So the same way you took weighted averages over here. So what you need to do is minus 2 times 1, 0 plus 1 times 1, 0. Okay. And so on. Like in the next row, there will be one more number over here, minus 2 times 0, 1. And so on. If you will take this and outside it is 1 by 6 because there are 6 quantities, you will get 1 by 6 and 6. Even if you see here that the first component will correspond to only the first row. So these two terms get cancelled. So 1 remains 1 by 6 over here. You can see, you can just calculate and you'll get it over here. Yeah. So next what is to be done is like match this user profile with every item that you have available in your catalog. And so whatever is most similar to this user profile, you recommend him this. Okay. I'll make this point more concrete. Okay. Now, one more thing is that I felt is there is another option to take average within a feature. What I mean is when I was taking average, I was taking it across actors. So yeah, so I was dividing it by the total number of movie. Let's say we had example something like this, actor A, actor B. and rating is something like, he rated it 2, 3, 5, 7, sorry, 2, 3, 5, 2, 2, 2, 1. And for the actor B has rated 5, 5. Okay. Because there is uneven number of like ratings, when you will take average over all the set, like when you are taking weighted average, what will happen is you will get low score for these quantities. Okay. Why? Because like there will be more 1, 0 kind of elements. So when you'll add all these things, it will get higher. But when you look intuitively, what you see that this person was watching a lot of movies of actor A, but he didn't like these movies a lot. Okay, he has watched a lot, but he didn't like it a lot. But for actor B, he has watched only 2 movies, but he's liking it very much. So what is natural? You should recommend him these kind of movies. So to do so, what you should do is, like for these kind of movie, you take a separate weighted average and you take separate weighted average for this. What I mean, just see. So it would be something like there are 1, 2, 3, 4, 5, 6, 7 movies. You take something like 1 by 7, 2 into 1, 0, plus 3 into 1, 0. Okay, you take it something like this. And for the other two, you take it something like 1 by 2, 5 times 0, 1, plus 5 into 0, 1. So that these movies don't impact how well he's liking this movie. So this can be useful in some application. The way that I suggested earlier can be useful in some other applications. You need to see like what problem you are working in and how does it fit to your problem. Okay. Now just a recap of what we have discussed till now. So if you have a catalog of items, okay, what you do, you make user profile for, sorry, item profile for every item. Let's denote it by vector I, let's say. For item I, it's I. Then using this item profile, you look at whatever the user has done in past and you come up with a user profile. Let's say U, the way we obtained just in the above example. Now, how to find like which I told you here that you have to match the user profile with every item that is available. How to do so? So you will take the cosine similarity for that. Why do we use cosine similarity? I covered this in week zero's content. If you are interested, you can have a look. Link is available on swayam. So we use cosine similarity to compare these two vectors now. So this user profile you created, I you have for every item. So you calculate this S for every item. This is just the dot product divided by the norms. Okay. So you calculate S for every item, then sort this S. Okay, sort in descending order. So for whichever item had the highest S, you keep it at top. The next item you keep just below it. You sort it this way. And then like when you see these examples that I showed you in the beginning, this didn't give you one recommendation. This generally gives you 4 to 5 recommendation at a time. Similarly over here, even if you look at the Facebook section, the people that you may know, the suggestion that they give you for friend, they give you 5 to 6 friends. So you need not select just one best thing, but you can select top K over here. Okay, so you need to get top K out of here. So you take top K. This K has to be decided by you, how you select this K. This depends on your space on the website or like whatever application you're working on, and then recommend top K from here. So this was something about content-based recommendation. If you have, so this is how content-based recommendation works. If you have any doubt, you can ask based on this. Then I'll move to collaborative filtering.
Why you are taking cos theta here function?
Okay, so one thing is like when you try to find oh, okay. So first I'll answer Yash's question. This is norm of U. So if you have a vector, let's say 1, 2, 3, it's generally 2 norm. Norm is defined as 1 square plus 2 square plus 3 square. So you took square root of it. So this is the like length of this vector. This is what is norm of U. So there are other definition of norm mathematically. You can have a look at something. So coming back to the question that someone asked, that why do we take cos theta? For the detail, I request you to watch last 4 or 5 minutes of week 0 content, but I'll give you a brief idea. whenever we represent some entity via vectors, okay, then it's always a good idea to find the distance based on the theta. Why I'm saying is, so because we are finding a vector and we are not keeping any constraint on length of the vector. So let's say we have a vector like this and we had a vector like this. So another natural option apart from cos theta is your Euclidean distance. You might know, like you want to find the distance between these two vectors. But these two vectors are same, but the Euclidean distance over here would be non-zero. So we don't want something like this. So what we want is we want this angle to be as close to each other. For more detail, you can just have a look over here. So this cosine is a good similarity that we get. Okay. Now, yeah. Okay. Any other doubt? Okay. So here are some advantages and disadvantages related to this content-based filtering. So one thing is, you don't need to know about any other user. Let's say you are the user. You need not know about the choices of other user or the company that is recommending you. Need not look at what people are doing around you, and it can recommend you based on your choices only. You'll find this advantage more useful when you look at collaborative filtering. So another thing is you can do it for very first user. So let's say you opened a new website. From the first user that is coming to your website, you can use this kind of recommendation system to recommend product to him. Okay. Next thing is it is able to recommend you unique things. Like people tend to have different tastes. Like some people like very unique kind of music. So it will be able to recommend them these kind of things. Next is it is able to recommend you new and unpopular things. So if something is new, not a lot of people have rated it, but it matches your interest based on whatever you have purchased in past. This algorithm would be able to recommend you those kind of things. Next and very important thing that I find about this kind of recommender system is that you can explain why you have made some kind of recommendation. So here is an example. So there was some guy, don't know his name. So he complained to IRCTC that this IRCTC app is showing him some vulgar ads. Okay. What IRCTC replied to him is that whatever ad it is showing to him is based on his browsing history and cookies that he has on his phone. So whatever recommendations that he was getting over here was based on whatever he has done in past. So IRCTC was able to explain why those kind of ads was popping. But if you look at something like collaborative filtering that we'll do next, you don't have this kind of explanation over here. So in many cases, this kind of explanation kind of becomes very useful. Okay. Now let's look at some of the major disadvantages. So finding appropriate features become very hard over here. Okay, so initially also I mentioned that finding features deciding upon the length of vector is based on the domain expertise, and that is not very cheap or can be done by the computer itself. Example is like if you have some images, extracting feature out of images, even music is very hard. Like you can say that the singer, this singer has sung this song, but still the songs are from different genre, and those kind of things. Those are very difficult to represent via this features. Another thing is there is very much over specialization about this kind of system. So if you are, let's say I'm moving to some hilly station to spend my vacations, and I bought something related to that. Even if I come back to my home, if I'm using this kind of recommendation, that website will keep recommending me things that are useful to go to hilly station and those kind of things, because it won't get out of the space out of the things that I have bought. Okay. This is another thing. So another thing is that you are missing upon the quality judgment of the other people. So whatever other peoples are buying, you are missing upon that. Yeah. Next is there is a something called cold start problem. So initially, if you do, you are a new user, you haven't bought enough things, then it is very difficult to recommend you something like when you have not bought anything. So there are some options to overcome this, like you can just recommend some popular things. So anybody, if you have like started using Amazon Prime Video or even Netflix for that matter, they ask you the movies that you like when you create an ID. So they ask you to select 3 movies initially so that they can recommend based on that. So you can use these kind of practices. Okay. So next is collaborative filtering. I'll okay. uh, I'll just wait a minute. Because we started late and I want to just at least give you some idea about it, but there is some issue with this NPTEL thing also. So I'll just try to fix this up. Okay. So now what a collaborative filtering is, that collaborative filtering is based on the relationship between users or items. So I'll say what it is. So what it try to does is it will find some kind of relation between one user and some user A and some user B. Now, if it sees that user A is related to user B, then what it does is it recommends things to user A that user B has bought. So it not only depends on what you have bought in past, but it kind of tries to see like if you have bought similar things, then it will recommend you based on whatever other person is buying. How is it different from this content-based recommendation is, in content-based recommendation, you looked at the features of just that item and you are not interested about what other people are buying or not buying. So this is a major difference between collaborative filtering and this thing. So I'll give you an example. So let's say a person, Amazon uses this. Yeah, Amazon uses item collaborative filtering. So like collaborative filtering is more popular when compared to content-based filtering. Sorry, content-based recommendation. But yeah, that is also so what happens in practice is they kind of use hybrid of both of these things. So both have their drawbacks and advantages. So they kind of uses both of them together. So yeah. So let's say person A buys some pen, pencil, book, and notebook, and B has bought some pen, pencil, and bag. Okay. Just a minute.
Pintu Kumar, sir,
Who is this?
could you postpone the session which is scheduled at 7, or could you make it early to finish your contents? Because we have
What
to
I'll
attend that session.
you can attend that session. What I'll do is I'll complete this session and you can watch the recording for rest of the session. There was some technical issue, so I can't help. So you can watch the session that will be available around half an hour after I finish the session.
Could you paste that link in the session in the window
Sure,
chat
sure,
box?
sure, sure. I have shared the link. Okay. So he is discussing PCA, feature selection, and some maths behind PCA, something like eigenvalue and eigenvector. Whoever is interested can join there.
Thank you.
Okay. So I'll continue with collaborative based filtering. Okay, just a second. There can be some disturbance for 1 or 2 minutes, whoever is staying, because I'm letting in people in other meeting that Mehnat is holding. Okay. So, so there are two kind of like collaborative filtering.
Sorry to interrupt, but I was asking regarding the this session's YouTube link. You have pasted
Okay.
the
So when you go to swayam, you will be able to see I'll tell you the exact name of what you will see. Just wait a minute. So there is something called solving session. If you go to that, you will find an Excel sheet. It will be uploaded over there. So you will find it after half an hour after I finish this thing. So you can just watch it over there. Okay. So right now it is not available because I have not uploaded it. Okay. Yeah. So I'll get back to this thing. Just a second. I will do something about it. Mhm. Okay. So there are two kind of collaborative filtering. One is user collaborative filtering, and another is item collaborative filtering. Okay.
So, hello
Yeah.
everyone. Can you hear me?
Yes, sir.
Yeah, please don't call me sir. You can call me Moinak. So, in the last class, up to the last class, we have we have just started supervised learning and seen some.
Okay. Now I'm ready for this thing. Yeah. So what we do is there are two kind of thing. One is user, another is item. So for user X, let's say we have some user X. Just if anyone is around, can you now I am putting my laptop on charge. Can you confirm that whether my audio is clear or not? Am I audible properly? Whoever is like,
Yes, sir.
okay, thank you. So this one that I'm talking about is something called user collaborative filtering. Okay. So let's say we have some user X. What we want to do is we want to find a user which is similar to X and recommend what that user likes. Okay. I'll give you an example. So this is like a user, and this is the movie that they have seen. You'll see that there are a lot of empty spaces. Like a lot of people have not seen a lot of movie, or they generally don't tend to rate these movies. Like even if you buy something, you not always rate everything. So this is an issue with the recommender system. So these movies are Harry Potter 1, 2, 3, Twilight, or Star Wars 1, 2, 3. This I picked from some other place. Arun, I'll share the YouTube link. Just wait for half an hour or so. Okay. So yeah. So what is happening is, if you look at this example, like person A has rated Harry Potter 1 4, person B has rated Harry Potter 5. This is only common rating between two. Okay. Now if you look at A and C, the person A has rated Star Wars 1 1 and person C has rated Star Wars 4. So if you look at this, what intuitively you can say is we want to define some kind of similarity between users. So we want similar users, but we have to define mathematically what we means by this similarity so that they capture this kind of thing. What is that? That A and B should be more close to each other than A and C. Okay, this is what we want to capture. Now, there are quite a few options. Ma'am told about Pearson coefficient, but I'll tell you about three of them, and I'll reach to Pearson coefficient towards the end, and I'll try to solve all of them. First is called Jacquard coefficient. Okay, what is Jacquard coefficient? We just look at quantity called this is number of movies that A has rated, and this is movies that B has rated. So we look at the set of intersection of the movies that both of them has rated divided by the total movies that they have rated together. Okay, if you look at this example, so A and B has rated one movie together. So I have written one at the top. Okay, and in total they have rated 1, 2, 3, 4, and 5 movies. So I'm dividing it by 5. Okay, so this is the Jacquard coefficient that is useful in comparing two vectors many times. Okay, so if you look at now the Jacquard coefficient between A and C, so they have rated two movies together, and in total they have also rated 1, 2, 3, 4, I think. Yeah, 4 movies. So it is 2 by 4. Now you look at this, what we are getting is that Jacquard coefficient of A and C is greater than A and B. Okay, so this is not a very good idea. So whatever it is not a good idea. So we wanted that A and B should be more similar to than A and C, but this is giving us the other way around. So the card coefficient is not a very good, but I'm mentioning it over here because this is kind of sometimes very useful in comparing vectors. Okay. Now, next similarity, that is our cosine similarity. Okay. What is cosine similarity? We are just using like A dot B divided by norm of A into norm of B. Now, to calculate this, you will see that there are a lot of missing entries over there. Yes. So you can find cosine similarity only if you have these entries, because you can find cosine similarity between vectors of equal length only. Okay. So to do so, what we do is we fill in these entries by 0. We put zeros over here. Okay, this is something we do. Ambika Hazarika, I'll share a recorded session, but that is only possible after I have finished this session. So I'll definitely share. You wait for it. I'll share it by tonight. Okay. Yeah, I'll just take one more minute.
This one, root 1, root 2, and you have 2 root 5s.
Okay,
So that's it.
where
And the
will I share? You go to your swayam where you can see all your videos. In swayam, you have a section called problem solving session. Okay, click on that. You'll be able to open an Excel sheet. In that Excel sheet, it will get updated. Okay. Okay. Now, next option that we had is this cosine similarity. Okay. So I have marked the missing values as 0, and I have taken the cosine similarities. You can try it on your own also. You can just see that this is 4 into 5, 20. Rest of the entries that are matching are 0. Okay. So it will be 20 on the top, and in the denominator is just the norm of these two vectors. Okay. Use a calculator, so you get something like 0.389. Similarly, between A and C, you get something between 3 to 9. Now we have achieved something that we wanted. That is, our S of A comma B is greater than S of A comma C. But what's the disadvantage over here is that this gap is very small. Like if you look at this person kind of, whichever movie that this person liked, he kind of hated that movie. And the other way around, where C liked a movie, this person A didn't like that movie at all. So there should be more gap between this. Why is this happening is that I rated all the other movies as 0, which is not true. Like the person has not rated these movies as 0. 0 is a very bad rating. At least what I should have done is I should have rated all of them as some average rating that a person is giving. Okay, so if you rate a movie on an average, so you are not imposing any positive or negative bias in that movie. You are rating them averagely. So we use the same technique in something called centered cosine. What we do is we subtract the average from every entry. By that, what we do is we make 0 as the average rating for every user. Okay, what we do for the first user, I found the average rating. So it is 4 plus 5 plus 1, which is 10 divided by 3. Again, for the next user, I found, for every user, I found. Then what I did is I subtracted this from every row. So I got a modified this utility matrix. Okay. Now, using this, I find the cosine similarity. After subtracting the average, I find the cosine similarity out of it. That when I computed, you can look at it, you can compute it. Between A and B, I found it to be 0.092. Between A and C, I found it to be negative 0.5. So there is this gap is also large. Okay. And apart from that, this negative sign also indicates that the interest of these two users are negatively aligned. This is another thing that you had to see. Now, if you want to see the closed form solution, so if you are given with A and B, we are trying to look at the closed form solution of whatever we did. So what we did is, first of all, from every entry, we subtracted their like averages. So for A also, for B also, we subtracted their average entry. Okay. And then we are taking their dot product. This is nothing but the dot product. We are multiplying them and taking the sum. This is dot product. So on top it is the dot product. This first term is your norm of this first row that you obtain after subtracting the average. Similarly, the second term is the norm of B after subtracting the average. Okay. So this is that we have obtained. This is called centered cosine similarity. Okay. Now, if you look at it carefully, this is same as the Pearson coefficient that ma'am introduced in the class. So this Pearson correlation is like existed before this in literature, in statistic literature, but we have get the same thing. So the basic idea why we use Pearson correlation is that we want the average to shift to 0. Okay. So now just a recap of what happened right now is we defined 3 notion how we can find the similarity between users. Okay. Similarity between users, and we found that this Pearson coefficient, correlation coefficient, or the centered cosine similarity is the best way to find similarity between the users. Okay. Now we know how we can find the similar users. Now the task at the hand is to predict rating for a movie. Okay. What we can do is we can choose K closest neighbor who has rated movie I. I'll show it by example. Let's say for this user A, we want to find what is rating for Harry Potter 3 that he would give. And whatever rating he gives, based on that, we want to tell whether he would be interested in watching this movie or not. So what we can do is we look at all the users that are possible. Okay. And then we take K neighbors that have rated that movie Harry Potter 3. And then we take average of their ratings. We can also take a weighted average of their rating based on the similarity between these K neighbors. So for every K neighbors, the similarity might not be same. It might vary from user to user. So we are taking a weighted similarity over here. Another thing that ma'am introduced in the class is like this is based on that average rating for every user is different. So we are this term is average rating of this specific user X. What is happening over here is we are looking at how much rating of this movie Harry Potter 3 is deviating from average rating from the specific user B. So if it is going positive, we should add something to the rating, that predicted rating. If it is going negative, we should subtract. So this is what is being captured by this formula. So this is what was introduced by ma'am. Okay, next is how to choose K. Again, it's a hyperparameter you have to decide on yourself. Okay. Any doubts on this? Okay, I'll just take 5 more minutes of your time. Before that, let me see if there are people waiting to join the other session. Just a minute. Just a second, sorry guys.
The universe. So that's not possible. So what will we do? We need to apply some greedy algorithms. If you do not have, if you
Okay, I'm back. So the one that I covered right now was user-user collaborative filtering. One which is more popular and used is item-item collaborative filtering. In this, what we try to do is we find okay. So this is just an example. I'll just cover example over here. What we try to find is we try to find similarity between items. Okay. I'll just give you an example to show what it is. So let's say we have these movie 1, 2, 3, 4, 5, 6, and these are the users that have rated it. So whatever is highlighted in yellow, those people have rated those movies that much. We want to know what should be the rating for user 5 for movie 1. Okay. Now what we do is we try to look for similar movies that are similar to movie one. How do we find similarity is same as how we found user similarity, that is based on your Pearson coefficient. Okay. So we can find that similarity between these movies. So I have written over here the similarity between movies, okay, when compared to movie one. Now, whichever movie we get similar and this person 5 has also seen, okay. So let's over here you see that this movie has high rating, this movie has good rating. So if I decide k equal to 2, that I take two neighbors, then we can take an average of these two ratings to be the rating that this person will give to this movie. So it would be 2.5. We can also take an weighted average based on the similarity. So it would be something like uh, that is your 2 into 0.4, because 0.4 was the score that this thing obtained, and 3 into 0.59. So we get something like 2.59. Okay. So this is something called item collaborative filter. And this is an example of item collaborative filtering. I have watched the movie Infinite, so they recommended me movie that were related to this movie. So they might have used the same algorithm to predict me this movie. Okay, now here are some advantages and disadvantages for collaborative filtering. This is not just for this item. So one thing is that this collaborative filtering works on any kind of data. You need not select features for this. You need not worry about what is the length of vector and what feature should I put in. You can work with any kind of data with this. There are a few disadvantages also. One is that it has cold start. Let's say there are not enough users or not enough ratings, then what to do? Okay. Next is like this is hard to find like users who have rated the same thing. Like even if you look here in this example, they have rated three movies each, but the overlap between let's say A and D is there are no movies that they have rated together. So finding similarity between them makes no sense. So this kind of problem occurs. After that, there is a problem of first rater. Let's say there is some new movie which is not rated by many people. Then how to recommend that movie? That movie won't come into any recommendation. Related to this is something called popularity bias, that popular movie tend to get recommended a lot to a lot many peoples. Now, just a last point, like how can you, well, let's say you made a hybrid recommendation system algorithm. But what I mean by a hybrid is you mixed both these, let's say collaborative filtering also you mixed item, you mixed user, and based on it you got some algorithm of your own. How do you judge its performance? Okay, what you do is you had some ratings like this. Okay, what you can do is you can hide a part of this rating. Let's say you hide this part of rating. Okay, then you try to predict this rating based on other ratings that are available. Okay, then you see how well you have performed on this data. If you have performed well enough on this data, then your algorithm is doing good. So this is what I had to offer today. If you have any doubt, please ask now.